Hey Wildcats, today we're looking at Thursday, March 7th, add and subtract rational expressions on page 61. Would update your table of contents. All right, now your table of contents are updated. Let's take a look at our notes. All right, add, subtract rational expressions on page 61. Adding and subtracting rational expression steps. Step 1, factor the denominator. Step 2, find the common denominator and multiply by a special one. Step 3, simplify the numerator. Step 4, factor the numerator and divide out common factors. So it would update your notes. All right, now your notes are updated. Let's take a look at examples on page 61. All right, simplify the following expression. All right, so notice whenever you're adding fractions, the denominator has to be the same. And when it's the same, you just add the numerators. So 1 plus 2 is 3, so it's 3 divided by 2. Now, when the denominators are the same, adding fractions is simple, okay, like example 1. But in example 2, when the denominators aren't the same, it's a little bit more complicated, okay? So here, what we need to do is we need to have the denominators to be the same, okay? So what we can do is we can multiply the 5 by 3 to make 15, so it'll be the same denominator. But the problem is you can't just do that, but you can do this. You can multiply 2/5 by 3 divided by 3. And the reason you can do that is because 3 divided by 3 is 1. So you're just multiplying that by 1, okay? So now, okay, 2 times 3 is 6, divided by 5 times 3 is 15. Now we can add 6/15 to 7/15. And remember, 6/15 is equivalent to 2/5, okay? Now the denominators are the same. So 6 plus 7 is 13, so you have 13 divided by 15. Okay. Now, same applies to example 3. Okay, we need to have the same denominator. Okay. Okay, well, the thing about it is we need to figure out what we can multiply to be the same. Okay, well, 12 can be written as 4 times 3. And 8 can be written as 4 times 2. So you can see they have a common factor of 4. Okay, so here I can write 12 as 4 times 3 minus 3 and 8 I can write it as 4 times 2. Now you notice I did example 2 in a very simple way, and I'm doing this on purpose in a more complicated way so you see how numbers can be broken down. Okay, now here we have a 4 and a 3. Okay, this has a 2, so we need this to have a times 2. This has 4 times 2 missing the 3, so now it's times 3. So here, now you see we're multiplying by the same 3 numbers, but you can't just multiply by 2. You have to multiply by 2 divided by 2 and 3 divided by 3. Okay? So 11 times 2 is 22. And then 4 times 3 is 12 times 2 is 24. Minus 3 times 3 is 9. And then 4 times 2 is 8 times 3 is 24. So then 22 minus 9 is 13. So that's 13 divided by 24. Okay, all right, so if you would finish up examples 1, 2, and 3. All right, let's take a look at example 4. So here, you'll notice they have the same denominator. When the same denominator, when you're adding fractions, the problem is simple. You just add the numerators, okay? And actually, there you go. So then we have 2x minus 3 plus 3x plus 4. Notice I took the numerators, put them all in the same denominator, and we're going to add them, okay? So now 2x and 3x is 5x, and then negative 3 plus 4 is positive 1, divided by 4x minus 1. And you're done. All right, so now, again, I purposely made example 4 simple with the same denominator so you could see how simple it can be when the denominator is the same. But now, example 5, actually, you know what? I'm sorry. I kept them both simple because one we're adding, one we're subtracting. Okay? So again, they're the same denominator. But here's where you have to be careful. When you subtract, you're subtracting all of this. So this needs to be in parentheses. Okay? So you have 3x minus 4 minus parentheses 5x plus 3. You're subtracting the whole thing. Okay? All divided by 4x plus 5. So that's 3x minus 4. And in this case, we're multiplying by negative 1. So negative 1 times 5x is negative 5x. And then negative 1 times 3 is negative 3. And then you combine terms. So 3x minus 5x is negative 2x. And then negative 4 minus 3 is negative 7. All divided by 4x plus 5. All right. Now, as you notice, as we go through the examples, they're getting a little bit more complicated, okay? So now let's take a look at example 6. Now here, the reason why I showed you how I factored out the 4, 3, and 2 is because in example 6, you're going to have to do the same conceptual idea here, but except for it's going to be x. So we need to factor this, okay? So we know we have x minus 1 divided by, we know that the denominator is 2 parentheses, we're going to factor it. We know x and x make x squared. Now we need to find all the combinations to make 2 and combine to be 3. So then that's 1 times 2 is 2. 1 plus 2 is 3. There's our factors, 1 and 2. So x plus 1, x plus 2. Plus, now here, this denominator is x plus 1, but it needs x plus 2. So we need to multiply this by x plus 2 divided by x plus 2. Okay? So now, they have the same denominator, we combine the numerators. So we have x minus 1 plus x times x plus 2, all divided by x plus 1 times x plus 2. So let's combine terms. We have x minus 1 plus x times x is x squared x times 2 is plus 2x, all divided by x plus 1 times x plus 2. Okay, so now we have x squared, 2x and 1x is plus 3x, and then minus 1, all divided by x plus 1 times x plus 2. Now, if you can, you want to factor the numerator. So let's see if we can factor that. So we need to find all the combinations that make -1 combined to be 3. Well, the only combination that makes -1 is -1 times 1, and -1 times or plus 1 is 0. There's no possible combination that will give you -1 and 3, so this is not factorable. So this is done. Okay, let's take a look at example 7. So here we have x divided by x plus 3 plus, that's weird to put it right there, plus -18. And now here we need to factor this. Well, this is easy because it's the difference of squares, so it's x plus 3 times x minus 3. So here, this denominator is x minus 3. This one needs it, so we need to multiply this by x minus 3 divided by x minus 3. Remember, we can do that because this divided by this is 1. So I haven't changed it, but I've updated the denominator so that we can combine it. Okay? So now we have, I'm going to go ahead and distribute that. X times x is x squared. X times -3 is -3x minus 18. Because we know once the denominator is in, we can combine the numerator. Divided by x plus 3x minus 3. Okay, now we need to see if the numerator can be factored. So we need to find all the combinations that make -18 combined to be -3. So -1 times 18 is -18. -1 plus 18 is 17. That didn't work. -2 times 9 is -18. -2 plus 9 is 7. That didn't work. -3 times 6 is -18. -3 plus 6 is +3. We have the 3. We want negative, so switch the sign. So 3 times -6 is -18. So 3 minus 6 is -3. We have our factors, 3 and -6. So we factor the numerator, so that's x plus 3 times x minus 6 divided by x plus 3 x minus 3. Now, why that's significant is because now this divides and becomes 1, and it simplifies to be x minus 6 divided by x minus 3. All right, so finish up example 6 and 7. All right, let's take a look at example 8. All right, so here again we need to factor the numerator, so we have 2x squared minus 16. And again, this is easy to factor because it's the difference of squares, so that's x plus 2 times x minus 2 minus x plus 4, I'm going to put that in parentheses, divided by x plus 2. And we need an x minus 2, so we're going to multiply this by x minus 2 times x minus 2. Okay. So now the denominator is the same. We can combine the numerators. So that's 2x squared minus 16 minus, we're going to go ahead and FOIL this. So x times x is x squared. X times -2 is -2x. 4 times x is positive 4x, and then 4 times negative 2 is negative 8, and that's all divided by x plus 2 times x minus 2. Now we need to continue to simplify the numerator. So we have 2x squared minus 16 minus 1x squared. We're distributing the negative 1, so plus 2x minus 4x plus 8, all divided by x plus 2, x minus 2. Okay, so now combine terms. 2x squared minus 1x squared is 1x squared. I'm going to do the x's next. So we have a 2x minus 4x is negative 2x. And what might help is if you shade them out as you combine them. It helps you see what you have left. Okay, and then negative 16 plus 8 is negative 8. All divided by x plus 2, x minus 2. Now again, we need to factor the numerator. So we need to find all the combinations to make negative 8 and combine to be negative 2. So negative 1 times 8 is negative 8. Negative 1 plus 8 is 7. That didn't work. Negative 2 times 4 is negative 8. And then negative 2 plus 4 is positive 2. That didn't work, but we got the 2, so we switched the signs. So 2 times negative 4 is negative 8. 2 minus 4 is negative 2. So our factors are 2 and negative 4. So this factors to be x plus 2 times x minus 4 divided by, and let's add another line here, x plus 2 times x minus 2. And you see here the x plus 2's divide and become 1. So you're left with x minus 4 divided by x minus 2. All right, so go ahead and finish up example 8. All right, let's take a look at example 9. Now, example 9 is just craziness because we have to factor this denominator and factor that denominator. Okay. All right, so we have x plus 7. Now we know 2 parentheses. You know x and x would make x squared. Okay, so now we need to find all the combinations to make 42, combined to be 13. So 1 times 42 is 42. 1 plus 42 is 43. That didn't work. 2 times 21 is 42. 2 plus 21 is 23. That didn't work. But we're getting closer to 13. So then I don't believe 3 works. Maybe it does. Let me double check. Now, when I need to find factors, this is what I do. I go to New Document, No, Add Graph, and I'm going to do 42 divided by X, Enter, Control T, and 3 does work. So 3 times 14 is 42. 3 plus 14 is 17. That didn't work. So now 4 doesn't work, 5 doesn't work, 6 works. So 6 times 7 is 42. And 6 plus 7 is 13. There's our factors. So x plus 6, x plus 7. So x plus 6, x plus 7 minus 10x divided by, and again, 2 parentheses. So x, and actually I need to leave room because in essence you're going to have to multiply this by something. minus 10x parentheses, and we know x and x make x squared. Now we need to find all the combinations to make 7 and combine to be 8. This is easy. X plus 1, x plus 7. Okay? And then again, we're going to have to multiply this by something here and here. Now, here, this has an x plus 6, x plus 7. It's missing x plus 1. So we need to multiply this by x plus 1, x plus 1. Okay. Here, this has x plus 1, x plus 7, missing x plus 6. So multiply by x plus 6, x plus 6. Okay. So then, this is a little, except I notice I'm not going to multiply all of this together. I'm going to do something unique in this case. I'm going to leave it as x plus 7 times x plus 1 now multiplied by negative 10x times x plus 6. The reason why I did it this way is because I noticed that some of those terms are in the denominator, so I can simplify. I can put the x plus 6 under here. I can put the x plus 7 under here. And I can put the x plus 1 under here. So I have the denominator, x plus 7, x plus 1, x plus 6, but these divide out. So this divides and becomes 1, divides and becomes 1, divides and becomes 1, and you're left with negative 10x and isn't that cool? All right, so if you would, finish up your example, start working on your assignments, and have a wonderful Wildcat day. But wait, if you stuck around the video, if I want to know if this and this is the same, I'm going to graph it. Now it's a little bit to graph, but I'm going to go to On, New Document, No, Add Graph, Control Divide, x plus 7 divided by x squared plus 13x plus 42 minus Control Divide 10x divided by x squared plus 8x plus 7 and my phone is ringing. It's no good. And so tab negative 10x. I knew it. So this tells me I made a mistake. Okay. And so that's why if you do something work and something comes out and you're like, you know what, that probably didn't work out like I thought it would be, then you graph it and you see, aha, it doesn't. So then you need to go back and reflect on your work. Okay. So this is correct. X plus 6, x plus 7, x plus 1 divided by x plus 7 times x plus 1 and then negative 10x and x plus 6 that's why, because I treated it like multiplication here, but no, I'm subtracting, so I can do that. No, I can't. That's why. That's where I went wrong. I have to keep the minus sign times 10x times x plus 6. That's where I made the mistake. You can't do that in multiplication. So then that's now I made a mistake, and you think, man, why'd you make a mistake? But sometimes mistakes are good. You can learn from them. And so what I hope you learned is that I got all this and became that. And then I was like, you know what? I don't know if that's correct. So if you graph this and your answer, they should be the same. And since they're not, it tells you made a mistake. So here, we're actually going to expand all this out, and it's all going to be divided by x plus 7, x plus 1, x plus 6. Okay? So here, x times x is x squared. X times 1 is plus 1x. 7 times x is plus 7x. And then 7 times 1 is plus 7. And then negative 10x times x is negative 10x squared. And then negative 10x times 6 is a negative 60x. Okay. So now we combine terms. X squared and negative 10x squared is negative 9x squared. And then I'm going to shade them out as I go. Okay. And then 1x and negative 60x is, oh wait, we have 1 and 7, that's 8, and negative is a negative 52x. So I'm going to mark those x's out. And then plus 7. Divided by x plus 7 times x plus 1 times x plus 6. In this case, I'm actually kind of glad I made a mistake because now I can show you is here, see that answer didn't overlap. So I'm going to tab, delete that one. I already have the original problem. Okay, so I can leave that tab. Now I'm going to press Control Divide. I'm going to graph this negative 9x squared minus 52x plus 7 divided by parentheses x plus 7 parentheses x plus 1 parentheses x plus 6. And voila, you see they overlap. Okay, so it's probably the best mistake I've made because I showed you how to check your answer. See, the original answer didn't overlap, so we were wrong. We fix it, and this overlaps, so we can verify that this answer is correct. Okay, so now finish up your examples and start working on your assignment and have a wonderful Wildcat